Hello my friends, and welcome back to Sky Creative. Today we're taking an incredible journey through 6 fascinating production processes that showcase the perfect blend of traditional craftsmanship and cutting-edge technology. So let's dive into the world of modern manufacturing excellence. Let's start our journey in the heart of Mexico, where the ancient art of Talavera pottery meets modern production efficiency. What you're seeing here isn't just tile manufacturing. It's a 500-year-old tradition that's been refined and systematized for today's market demands. The magic begins with Talavera's secret weapon, the unique clay composition. This isn't your garden variety clay, folks. The factory sources 2 specific types of clay, a dark clay from the local hillsides and a lighter sandy clay from the valley floors. Watch as these massive pug mills blend the clays in precise ratios. These industrial mixers, weighing over 3 tons each, can process 2,000 pounds of clay per hour while maintaining the exact consistency that's made Talavera famous for centuries. The aging process is fascinating. After mixing, the clay rests in humidity-controlled chambers for exactly 3 months. This isn't just tradition, it's science. The aging allows mineral particles to achieve optimal plasticity, creating that distinctive workability that Talavera artisans demand. Now here's where tradition meets technology beautifully. While machines handle the initial pressing and basic shaping using hydraulic presses generating 15 tons of pressure per square inch, the real artistry happens next. Master craftsmen, many following techniques passed down through generations, hand-finish each tile using specialized tools that look almost medieval but are precisely engineered for their purpose. Notice the quality control happening at every station. Each tile is inspected for thickness uniformity. We're talking tolerances of just 2 millimeters across a 6-inch tile. Any deviation, and it's back to the clay pile. This is where modern chemistry revolutionizes ancient art. The glazing booth uses computer-controlled spray systems that apply exactly 0.3 millimeters of glaze with 99.7% consistency. But here's the kicker. The glaze recipes themselves are still mixed by hand, according to formulas some families have guarded for over 2 centuries. The hand painting station is pure poetry in motion. These artisans use brushes made from specific animal hairs, badger for fine lines, ox hair for broad strokes. Each painter can complete a complex geometric pattern in under 90 seconds, yet no 2 tiles are exactly identical. That's the beauty of controlled human variation in manufacturing. The kilns are engineering marvels. These aren't your pottery class kilns. We're looking at computer-controlled furnaces that maintain temperatures within 5 degrees of the target 1,850 degrees Fahrenheit throughout a 14-hour firing cycle. The kiln cars, weighing 4 tons when loaded, move through temperature zones with the precision of a Swiss watch. The final quality inspection uses digital imaging systems that can detect color variations invisible to the human eye, ensuring every Talavera tile meets export standards while maintaining that authentic, handcrafted character that makes them so prized worldwide. Welcome to one of Zimbabwe's most sophisticated gold mining operations, where Caledonia Mining Corporation has transformed the historic blanket mine into a showcase of modern extraction technology. This isn't your grandfather's gold rush. This is precision mining at its finest. What you're witnessing 750 feet below ground is remarkable. Caledonia's mechanized mining fleet includes load haul dump vehicles that can transport 10 tons of ore per trip through tunnels barely wide enough for a pickup truck. These diesel-electric hybrids navigate using laser-guided positioning systems, accurate to within 6 inches in complete darkness. The drilling operation is choreographed like a ballet. Each blast hole is positioned using computer-generated drilling patterns that optimize ore recovery while maintaining structural integrity. The pneumatic drill rigs deliver 2,400 impacts per minute, with pressures reaching 180 psi, but watch the precision. Each hole is drilled to exactly the specified depth and angle. Above ground, the processing plant is where raw earth becomes precious metal. The primary jaw crusher can pulverize 400 tons of ore per hour, reducing basketball-sized rocks to 6-inch fragments. But the real magic happens in the ball mills. These rotating drums, containing 40 tons of steel balls, grind ore to particles finer than talcum powder. The flotation cells are fascinating to watch. By controlling pH levels, air injection rates, and chemical additives down to parts per million, operators create conditions where gold-bearing particles literally float while waste rock sinks. It's chemistry and physics working in perfect harmony. The gravity separation circuit uses technology that would amaze the old prospectors. Falcon concentrators generate centrifugal forces 300 times stronger than gravity, separating gold particles weighing just micrograms from worthless material. The recovery rate? An impressive 94.7% of available gold. The final smelting process reaches temperatures of 2,100 degrees Fahrenheit in induction furnaces that can melt 500 pounds of concentrate in just 45 minutes. Watch as molten gold, glowing like liquid sunshine, flows into ingot molds. Each bar represents approximately 28 tons of ore processed through this incredible system. Environmental responsibility is built into every process. The tailings management system recycles 85% of process water, and the underground paste backfill operation converts waste into structural support, eliminating traditional tailings dams. Now let's explore how German engineering excellence is revolutionizing affordable housing. Redtech GmbH's Upcrete system represents a quantum leap in modular construction, combining sustainability with industrial precision that only German engineering can deliver. What makes Upcrete special isn't just what goes into it, it's what doesn't. Traditional concrete production generates massive CO2 emissions, but Redtech's proprietary blend incorporates 70% recycled materials, including industrial waste, fly ash, and recycled aggregates. The result? Concrete that's actually carbon negative over its lifetime while maintaining superior strength characteristics. The mixing facility processes materials with pharmaceutical-grade precision. Computer-controlled dosing systems measure ingredients to within 0.1% accuracy. The automated batching plant can produce 120 cubic meters of Upcrete per hour, with each batch tracked by RFID technology from mixing through final installation. The production line resembles a sophisticated assembly line more than a construction site. Steel reinforcement cages are robotically welded using precise specifications calculated by structural analysis software. These aren't approximations. Every weld point is exactly where computer modeling determines optimal stress distribution. Watch the casting process in action. The heated molds, maintained at exactly 140 degrees Fahrenheit, receive Upcrete through computer-controlled pour systems that eliminate air bubbles and ensure uniform density. The vibration tables generate specific frequency patterns that consolidate the material without segregation, a critical factor in achieving the 40% higher strength than conventional concrete. The climate-controlled curing chambers maintain temperature and humidity within narrow tolerances for optimal strength development. Steam curing at 180 degrees Fahrenheit for 16 hours achieves in one day what would normally take 28 days without compromising long-term durability. The finishing stations are marvels of precision. CNC routing machines create window and door openings with tolerances of plus or minus 2 millimeters, while integrated conduit and plumbing channels are formed during casting, eliminating the need for drilling and cutting on site. Quality control uses ultrasonic testing that can detect internal defects invisible to the naked eye. Each module undergoes structural testing equivalent to 150% of design loads before shipping. The result? Housing modules that can be assembled on site in hours rather than months, with construction quality that exceeds traditional building methods. Let's journey to the Namibian desert, where Ohorongo Cement operates one of Africa's most advanced cement production facilities. This isn't just about making cement. It's about creating the building blocks of a nation's infrastructure using technology that transforms desert rock into construction gold. The story begins in Ohorongo's limestone quarry, where precision blasting techniques extract 2,000 tons of raw material per hour. These aren't random explosions. Each blast is designed using 3D geological modeling software that maps rock formations to optimize fragmentation while minimizing environmental impact. The primary crusher, a massive machine weighing 180 tons, reduces house-sized boulders to manageable chunks. But here's what's impressive. The crusher's wear-resistant components are replaced robotically, minimizing downtime and ensuring consistent particle size distribution critical for quality cement production. The raw mill is an engineering marvel. A horizontal cylinder, 4.2 meters in diameter and 14 meters long, containing 280 tons of grinding media. This rotating giant processes limestone, clay, iron ore, and silica sand into a powder so fine that 90% passes through a sieve with 90 micrometer openings. That's finer than flour. The heart of the operation is the rotary kiln. Imagine a rotating steel tube 4 meters wide and 62 meters long, lined with specialized refractory bricks that withstand temperatures reaching 2,700 degrees Fahrenheit. The kiln rotates at precisely 3.5 revolutions per minute, creating a slow-motion waterfall of raw material that takes 4 hours to travel from feed end to discharge. The preheater tower, standing 80 meters tall, uses waste heat from the kiln to precondition raw materials. This ingenious heat recovery system reduces fuel consumption by 40% while ensuring optimal chemical reactions. Watch as materials cascade through 5 cyclone stages, each precisely calculated to maximize heat transfer efficiency. The finish mill transforms clinker into cement powder with blade fineness of 350 square meters per kilogram. If you could unfold all the particle surfaces in 1 kilogram of cement, they'd cover nearly an acre. The closed-circuit grinding system with high-efficiency separators ensures optimal particle size distribution for maximum strength development. The automated quality control laboratory analyzes samples every 30 minutes using X-ray fluorescence spectroscopy and automated strength testing equipment. The system can detect chemical variations of 0.01% and automatically adjust raw material proportions to maintain consistent quality. Ohorongo's environmental systems are equally impressive. The electrostatic precipitators remove 99.9% of particulate emissions using 40,000-volt electrical fields that charge and capture dust particles. The alternative fuel system co-processes waste materials, reducing landfill dependency while providing renewable energy for the kiln operation. From the Netherlands comes revolutionary technology that's literally printing the future of housing. Casco Total's 3D Beton Casco system represents the cutting edge of automated construction, where robots build homes layer by layer with precision impossible for human hands. The star of this operation is the massive 3D concrete printer, a gantry system spanning 12 meters that moves with millimeter precision while extruding specialized concrete mix through a 5-centimeter nozzle. This isn't your desktop 3D printer scaled up. It's a purpose-built construction robot that can print a complete house shell in just 120 hours of continuous operation. The concrete formulation is crucial. It must flow through the printing nozzle, yet set quickly enough to support subsequent layers. Casco's proprietary mix includes accelerating agents, fiber reinforcement, and plasticizers that create a material with 30% higher compressive strength than traditional concrete, while remaining printable for exactly 90 minutes after mixing. Watch the precision as each layer builds upon the previous one. The printer deposits concrete in continuous ribbons, with layer heights of exactly 2.5 centimeters. Temperature sensors monitor curing in real time, adjusting print speed to ensure optimal bonding between layers. The result is a monolithic structure with strength characteristics superior to traditional block construction. The integrated reinforcement system is ingenious. Steel cables are inserted into designated channels during printing, creating post-tension structures that can withstand seismic forces. Window and door frames are positioned robotically during the printing process, eliminating the need for subsequent cutting or modification. The magic happens in the finishing bay, where printed shells receive mechanical, electrical, and plumbing systems through automated installation processes. Robotic arms install prefabricated utility modules with positional accuracy of plus or minus 1 millimeter, ensuring perfect alignment of connections and fixtures. The insulation system uses expanding foam injection that completely fills cavities within the printed walls, creating R values 40% higher than conventional construction. Thermal imaging confirms complete coverage, eliminating thermal bridges that reduce energy efficiency. Quality assurance uses drone-mounted laser scanning that creates 3D models accurate to within 2 millimeters, comparing actual construction to design specifications. Any deviations are automatically flagged for correction before the module leaves the factory. Our final stop showcases the pinnacle of precast concrete technology, the Maxtruder system that's revolutionizing how we manufacture everything from bridge beams to architectural panels. This is automation and precision engineering working in perfect harmony. The Maxtruder itself is a marvel of mechanical engineering, a 40-meter-long production line that combines mixing, extrusion, and forming in one continuous process. The twin-screw extruder, borrowed from plastic manufacturing technology and scaled up for concrete, achieves mixing uniformity impossible with conventional methods. Material feeding is completely automated. Precise dosing systems deliver cement, aggregates, water, and admixtures with accuracy measured in grams per cubic meter. The computer-controlled system can adjust mix proportions in real time based on material moisture content, temperature, and ambient conditions. Watch as the extruder produces perfectly formed concrete profiles at speeds up to 8 meters per minute. The die system, machined to tolerances of plus or minus 0.5 millimeters, shapes concrete into complex geometries while it's still plastic. Hollow core slabs, structural beams, and architectural panels emerge with surface finishes that require no additional treatment. The immediate tensioning system is particularly impressive. Steel strands are stressed to 75% of their ultimate strength and locked into position before concrete placement. As the concrete cures and shrinks, it grips the steel, creating pre-stressed elements with load capacities 3 times higher than conventional reinforced concrete. The flying saw system cuts moving concrete to exact lengths without stopping production. Diamond-embedded blades spinning at 3,600 RPM slice through reinforced concrete like butter, creating perfectly square ends with dimensional accuracy of plus or minus 3 millimeters over 15-meter lengths. Automated handling systems use vacuum lifting technology to move 20-ton precast elements with the delicacy of picking up an egg. Position sensors and load cells ensure elements are placed exactly where specified, eliminating the risk of damage during handling. The surface finishing station applies architectural treatments ranging from smooth as glass finishes to textured surfaces that mimic natural stone. Robotic spray systems apply protective coatings with uniform thickness, ensuring decades of durability in harsh environments.